All right. All right. Well, hello, everyone. I'm Ana Baciero, and I'm going to share with you a study we have done on the processing of logos. So I'm positive that all of you have noticed that logos are almost everywhere we go. They represent organizations, products, entities, but we are also surrounded by counterfeits, created by slightly modifying the spelling of popular brand names while keeping a similar global shape and design, so the resulting items can be easily mistaken for the original products. Indeed, around 20% of customers unintentionally buy items that look like an original brand. And as we can see in the pictures here, many of these counterfeits are created by transposing letter names. In the word recognition area, it is understood that encoding the position of the letters within a word is a flexible mechanism, since we are all capable of reading words and sentences with scrambled letters. Within this general understanding, there are two main families of models. On the one hand, we have the orthographic approach, here represented by open bigram accounts, that suggests letter position coding happens at a level of processing where linguistic information is stored as letter pairs, so open bigrams. And on the other hand, we have the perceptual approach, position uncertainty accounts, that suggest there is some uncertainty or noise associated with position due to the limitations of the visual system. Therefore, the letters within a word activate not only their own position, but also nearby positions. And all these theories are based on word recognition research. But what about logos? They represent a very special type of printed stimuli for reading research because they provide consistent visual information across different contexts. They always use the same specific typeface, color, and design, hence making the whole percept easily recognizable. I'm sure you don't have to read the word Coca-Cola here to know that it says Coca-Cola. So perhaps such graphical information makes them more susceptible to deception by misspelling. In a recent study, Pathak and colleagues asked participants to decide whether a logotype was correctly spelled or not. These logos could be presented in their original form or with a transposition of the initial or final two letters, as we can see here. And they found higher response times and error rates for misspelled logos with the final letter transpositions, which is also a common finding in word recognition research. However, their studies had some limitations. For example, they didn't have a control condition, so there were no replacement letters. And also, they didn't use logos, which leaves the nature of the effect unclear, since it could just be that the transposed letter effect is parallel to the one found in with common words in word recognition research. So there are still some relevant questions to be addressed. For example, to what degree graphical information modulates the ability to distinguish authentic from misspelled brand names? And more specifically, what is the role of letter style in the identification of logos? With the final goal in mind of implementing a model on logo or word identification. So the aim of the present study was to examine the role of graphical information on the detection of misspelled brand names. To that end, we carried out two experiments. The first one, in the first one, we compared participants' performance at detecting misspelled brand names presented either as the full logo or in plain format, just written in Times New Roman, as we can see there. And in the second experiment, the comparison was between full logos and the brand name with the letter style used in the logo, as we can see here too. In both experiments, participants had to decide whether a brand name was spelled correctly or not. Half of the trials involved the original items, and the other half were misspelled or counterfeit items. And for those counterfeit items, we either transposed or replaced two internal letters of the brand names. The replacement were the orthographic control. And what did we find? For experiment 1, as can be seen in the summary table here, transposed letter items were responded to more slowly than misspelled plain brand names. Sorry. In addition, the transposed letter effect was greater for misspelled full logos than for misspelled plain brain names. And the same trend was found in error data. In experiment 2, we found similar results, slower responses to transposed letter items than to replacement letter items. Misspelled typeface-only logos were responded to more slowly than the misspelled full logos, and the transposed letter effect was greater for full logos than for misspelled typeface-only logos. Although this was smaller than in experiment 1, suggesting that the typeface alone, in the absence of other graphical information, makes the item quite similar to the original logo. And yeah, there. And it is important to note that the higher confusability of the misspelled full logos occurred in an orthographically based task. So the presence of or absence of the graphical information was not diagnostic of the response. From the theoretical point of view, our findings show that when we encounter a logo, the process not only we process not only its orthographic information, but also its graphical information. And keep in mind that an orthographically based account of word recognition would have predicted similar transposed letter effects in all formats, since the percept from a transposed letter logo would be very similar to the stored representation of the original logo, regardless of graphical information. Moreover, it is possible that we don't encode accurately the specific details that characterize highly familiar objects, such as logos. That is, because we see the logos always in the same layout, we don't need detailed information to access their stored representation. And finally, from the applied point of view, our findings can be used to guide the decisions on whether a potential lookalike brand name is too similar to a well-established brand name. That is, one would need to consider not only the names, but also the graphical information in which they are embedded. Thank you very much. And if you have any questions, I'm here.
Thank you very much for your presentation and very nice results. So yes, we do have time. Any hands or any typed questions?
Oh, well, I just wanted also to let you know that we already have the paper under review. So if you want a copy or something, please ask for it.
Okay, thank you. We have a question from Yuri Shterov.
Yeah, thanks. Thank you very much for an interesting presentation. I have sort of question about regarding your applications. So how much of the logo perception is actually orthographic? And can you disentangle the orthography from purely graphical effects? I don't know, maybe using other stimuli that don't include logos, that don't include letters. I don't know, take Apple with a byte on the left or right side for the Apple computers logo or something.
Right.
Like that.
That is.
Can you
sorry,
can you disentangle these sort of? So are logos holistically perceived, or are they still read? That's kind of and what determines that?
So I think that is a great question, and that is the question we wanted to at least to start disentangle, or at least to start answering with these experiments. I do believe that they are perceived more holistically than words, for sure. They have all this graphical information, and we don't know yet. We need to do some more further experiments, but to determine exactly what what is the weight of orthographical information here. But they do use orthographical information. They all have a name, and actually, eventually, if the brand is very is well known, at some point, many logos start dropping the word, the orthographic information, and just use an image, such as Apple, right?
Okay.
So yeah, I don't know what is the weight of the orthographical information, but that is, I mean, it is used at the beginning for some reason, for sure.
Yeah, thank you.
Yeah, thank you.